This is EC Digital Signal Processing Homework 3, Problem 7. We now have an LTI system has zeros, HZ1 equals 1/3 and Z2 equals 3. And we have a double pole at Z equals 0. Problem A. If the DC gain is to be 1.0, find H of Z. From the lecture note, we know that the DC response of a system is the response to the constant input x of n equals 1. Since 1 equals e to the j omega of n with omega equals 0, the above result tells us that the DC response of system Hz is h of e to the j 0, which is h of 1. So let's do the problem A. Since that we know Z1, Z2, and since we know the zeros and poles, we can easily get Hz equals Z minus 1 over 3 times Z minus 3 over Z to the power of 2, and we need to multiply a constant C. The DC response, which I have stated above, is H1. That equals 1.0 from the statement of the question, which is C times 1 minus 1/3 times 1 minus 3 over 1 to the power 2. Thus, we can easily get C equals minus 3 over 4. So the final Hz is minus 3 over 4 times Z minus 1/3 times Z minus 3 over Z to the power of 2. Problem B. Find the impulse response of the stable inverse system, G of Z. From the lecture, we can get that the inverse system is 1 over H of Z, which is minus 4 over 3 times Z to the power of 2 over Z minus 1/3 times Z minus 3. And we do the partial differentiate, which is 1 over 6 times Z over Z minus 1/3 minus 3 over 2 times Z over Z minus 3. If G of Z is stable, it means region of convergence must contain unit circle where Z absolute value is 1. So it's obvious that Z should be greater than 1/3 and smaller than 3. It means the first part of G of Z, it should be a causal system, and the second part, it is an anti-causal system. Thus, G of n equals 1 over 6 times 1 over 3 to the power of n times U of n plus 3 over 2 times 3 to the power of n times U of minus n minus 1. That is the solution to the problem 7.